Hello children, you're welcome to this segment of the program. It is mathematics time, and that means it is time to have some fun. Today in mathematics, we are moving on to a topic that is very interesting. We will be studying everyday statistics, and I'm sure you're looking forward to that. But before we go into it, a review of the correction to our last assignment is in order. We're asked to find the scale given the paper length and the actual length of the following. The answers will come up right about now. Now, comparing 40 centimeter to 1,800 centimeter, by the time we reduce to the lowest terms, we get 1 to 45. Now, comparing 50 centimeter to 100 meters, first we change 100 meters to centimeters, and that will give us 10,000 centimeters. And when we reduce that to the lowest term, we'll get 1:200. Just to be sure, you get 50 centimeter times 200 will give you 10,000 centimeters. Now, number 3 says compare 5 centimeter to 80 meters. First, we change 80 meters to centimeters, and that is 8,000 centimeters. Now, when you compare 5 centimeters to 8,000 centimeters and reduce to the lowest terms, you will get 1 to 1,600. Number 4 says compare 60 centimeter to 0.3 kilometers. 0.3 kilometers, that is 300,000 centimeters. And when you reduce that to the lowest term, you get 1 to 5,000. Finally, 240 millimeters, that is the same thing as 24 centimeters. 24 centimeters here. 600 meters, that is the same thing as 60,000 centimeters. Now compare 24 centimeters and 60,000 centimeters. Reduce it to the lowest term, you get 1 to 2,500. Now, I believe that a lot of you got this right, and for that I'm going to celebrate you with a chair. Now, moving on to the topic for the day, we begin by looking at the expected learning outcomes. By the end of this lesson, you should be able to convert data to a tally chart, and also you should be able to read and interpret a pictogram and answer questions from it. Now, what exactly is statistics? Now, I'm going to guess that a lot of you cannot say statistics 3 times. Like statistics. Try that during your leisure. Statistics is the mathematics of working with data. But what exactly is data? Now, data are facts and information about a thing or a person. For example, Umar is 11. That is a fact or piece of information about Umar, and that is data. What other piece of information do we know about Umar? He is 54 centimeters tall. That's another piece of data about Umar. He weighs 38 kilograms. That's another piece of data about Umar. He is in primary 6. That's another piece of data about Umar. And his favorite food is rice. All these, my friend, are data about Umar. Now, you compare Umar to yourself. You're also in primary 6. Now, the data for Umar will be different from your own data, because data from one person is different from another person. Data is different for different people. So, where Umar likes rice, you may like yam. Some other person may like noodles. Now, this data is different. Now, when data is not organized, it can be confusing and difficult to understand. Like I said earlier, in statistics, we study data. We want to organize it. We want to get meaning out of it. Now, this piece of data is talking about the mode of transportation that is preferred by 50 pupils. Can I get a zoom on this? If you try to study this data, it will be difficult for you to make sense of it. How many people go to school with bicycle? How many people go to school with their legs? How many people trek to school? How many people go in their private car? How many people go by public bus? Let's go back to that previous page. Now, like I said, this data represents the mode of transportation preferred by 50 pupils. Moving on, this data is very confusing, okay? But the same set of data can be represented in another way that is a lot better and that makes sense. Let's see. Now this set of data is the same as this one. Let's zoom in on this one. Going to school. Now, it is very easy to see that 17 people go to school on the bicycle. It's easy to see that the least used mode of transportation is by public bus. 11 students trek to school and 16 of them go with the car. Going back to that previous saying, the same data is also organized here, and it is easy to see. It's also organized here as well. So all these are ways of organizing data. It makes us easy to see that, okay, the people that go to school by bus are the least, and the people that go to school by bicycle are the most. These are just some of the ways of organizing data. And using these methods of organizing data is very easy to see, and it helps you to make decisions quicker. Rather than if you were faced with that first one, let's go back. If you were faced with that first one, you're going to have a long and difficult time organizing and making sense of this data. Let's move on. Now, studying data provides us with answers to many important questions and allows us to make useful decisions. For instance, if probably government wants to provide school bus for some pupils in the school. Now, studying this data, they can see that 22% of all the students trek to school, and they know just exactly how many school buses or the capacity of the school buses that they are going to provide. We can only get this answer by studying data using statistics. Now, let's now go into how we as pupils can organize data. The first one we want to look at is the tally method. It's the basic step. Let's see what that is all about. Now, the tally marking is a way of organizing data by looking at that data and ticking off with every item of data that you see, you make a tick. If you see bicycle, you make a tick. If you see a car, you make a tick. Tally strokes are counted in fives, as you will see in the next screen down. The fifth stroke, now when you write your tally marks, for one item of bicycle that you see, you make one mark. Another item of bicycle, you make another mark. Another item of bicycle. By the time you get to 5 bicycle, the fifth mark, you will cross it like is shown here. See, 1, 2, 3, 4. Then you usually use the fifth stroke to cross the first 4, and you count in fives. Let's see this in practice. Now, these are some balls that were found in a sack. Now, the teacher is confused. He doesn't know how many red balls are there, how many green balls are there, which color of ball appears the most. Looking at this data, my friend, you find that this is confusing. It's very difficult to answer these questions at a glance. But if we apply the statistical method, the tally method, we'll be able to see quickly how many are there. So we will rearrange these balls, bring all the reds together, all the greens together, all the yellow together, and all the blue. And now we see that there are 9 red balls, 11 green balls, 14 yellow balls, and 16 blue balls. But how do we organize this information on a tally chart? To draw your tally table, before that, please, to draw a tally table, you are going to draw 3 columns. Now let's zoom in on this column and see how exactly you organize your tally table. Now, you're going to put the data you want to work with. That's the color of balls. And in this case, we're working with red, green, yellow, and blue. Now, how many red balls are there? 9. How many green balls? 11. How many yellow balls? 14. How many blue balls? 16. Now, about that tally, you start ticking off for the red balls. 1, 2, 3, 4, 5. 6, 7, 8, 9. There is no fifth one that you use to cross. So this essentially means 9. When you see a group of tally marks like this, that means 5. And if you see any other one that has not been crossed, then you count singularly. 1, 2, 3, 4. Add 4 to 5, you get 9. Let's see how 11 is going to be represented using the tally marks. So groups of 5, 1, 2, 3, 4, 5, 10, and then 1 extra, making 11. So you count in fives. Let's see how 14 is going to be represented. Group, another one, 1, 2, 3, 4, 5, group, another 4 extra. So this is 5, 10, and then extra 4, making 14. So that's how you read your tally chart. Now this one, how many is it? Let's see, let's go. Let's go. So if I want to count this, I'll just go 5. I won't have to count one by one. Just go 5, 10, 15, then one extra, making 16. Now I'm just going to test you and see how well you have understood this. Let's move on. Moving on. This is a summary of that tally at a glance. So moving on. The one I call count here, sometimes you might see it in your books and they write it as frequency. It's still the same thing. It means how many red balls, and that is 9. So the count is 9, or you say the frequency is 9. I use count so that you can remember is how many you get there is something you can count. So, but if you see frequency, it's still the same thing. Now, I want you to study this tally table and write exactly how many. The table represents the favorite food of some pupils. So I want you to study and tell me how many pupils like rice, how many like noodles, how many like beans, and how many like yam. You have just 30 seconds for this. Begin. Alrighty then, eyes on me. I believe that you are done by now. Let's now say the correction to this. Rice, how many pupils like rice? That's 5, 10. Don't forget we count in fives. 5, 10, and an extra 2, making 12. Here, just 1 5 and an extra 3. Altogether, we have 8 pupils liking noodles. This one is just 4 because it's not up to 5. There is 2 cross. So we have just 4. And now this one is 5, 10, 15, plus an extra 1, making 16. I believe you got all that correctly. That means that you deserve a chair. Now let's move on to the next thing. Pictograms are a very, very beautiful way of organizing our data. We call them data in pictures. But what are pictograms exactly? They are a way that we represent data that use pictures that are related to the data. I'll take that again. Pictograms are a way of representing data using pictures that matches that data. So for example, the other time when we're talking about children who take bicycles to school, if there are 5 children, then we'll probably use 5 images of bicycle to represent that data. Now, pictograms come in vertical form like this one here. They go up, okay, so, or they come in horizontal form, they go to the side. Moving on. Sometimes in a pictogram, a picture can represent many items of data. For instance, like that bicycle. If there are 1,000 pupils that take bicycle, I mean, it will not be easy for us to draw 1,000 bicycle. So we'll probably just use one image of a bicycle to represent a number of bicycle. So this is called the key of that pictogram. Now look at this picture very well. It says one image that you see represents 10 trees. That is the key. So whenever you see just one image, 10 trees. So here we have 10 trees, 10 trees, 10 trees, altogether 30 trees. It is easy to represent data this way. So my friend, when you're working with pictograms, always look for the key, because without the key, you will not be able to answer questions correctly on pictograms. Here is an example. This pictogram represents the number of apples sold by a trader in 4 months. Now, what are the questions to be answered from these? First question says, what is the key? Like I have said, you have to look for the key when you are working with pictogram. To answer this question, we have to look deeper into the image that is given. Now, below it says, one image here is 10 apples. Half of an image is 5 apples. Let's go on. That exactly, my friend, is the key. One image, 10 apples. Half image, 5 apples. That is just the key. The next question says, how many apples were sold in January? So I go to January and I see that there is just one image. And don't forget that the key says one image represents 10 apples. So January sales, one image, and that means 10 times 1, and that means 10 apples were sold in January. Number 3 question says, how many more apples were sold in February than in March? Again, how many more apples were sold in February than in March? So we want to find out by how many apples February sales are more than March sales. So let's go. February sales are easy to count. One image means 10 apples, so we count 10, 20, 30, 40. That is 10 times 4, and you get 40 apples for February sales. Now, March sales, we just have 10, 20, and then that half, making 25. 10, 20, then that half, making 25. So altogether, 25 apples were sold in March. So what is the difference between these two? The difference is 40 minus 25, and that is 15 apples, which means that February sales are 15 apples more than March sales. Working with pictograms is actually very, very easy. All you need to do is look out for the key and count the data. Now I want you to do this. How many apples were sold in April? It's right there on the board. How many apples were sold altogether? It's also right there on the board. And do not forget that one image means 10 apples. Half of the image means 5 apples. You have just 1 minute, my friend. Begin. Eyes on me. Let's see just how many apples were sold in April. In April, we have just 2 images, and that is 10 times 2. That's 20 apples, just 10, 20. Altogether, we have to count 1, 2, 3, or let's count in tens. 10, 20, 30, 40, 50, 60, 70, plus this one, 5, 75, 85, 95. Which means that altogether in the 4 months, 95 apples were sold. I believe that you got that right. Now, let's move on to our homework. You are to study this table. Now, answer the questions after studying the table. Which fruit has the most trees in the garden? This image represents the number of fruit trees in a garden. So now we say, which fruit has the most number of trees in the garden? How many more peach trees are there than apple trees? Finally, how many trees are there in the garden all together? Copy this and do them during your leisure. Now we've come to the end of the mathematics segment. I will now hand you over to Uncle Popo for the general studies class. Till I come your way next time, remain wonderful mathemagicians.